Hi class, in this video I am working out example 5 on page 62 in your note packet on implicit differentiation. So we got to find dy over dx, the derivative of y with respect to the independent variable x, and the equation we're differentiating is e to the xy power is equal to 10y. So using the rules of differentiation that we've learned, when we differentiate the left-hand side, we differentiate e to the xy, where this is a natural exponential function. The derivative of the natural exponential function is itself e to the xy in this case, okay? And then we have to, by the chain rule, we have to multiply that by the derivative of the exponent. Okay? Well, the exponent is a product of two functions. X is the first function, and y is the second function. So in differentiating x times y, we got to use the product rule. And the version of the product rule that I've been using this semester is the first function times the derivative of the second function plus the second function times the derivative of the first. Okay. And again, as I've said in the past, your version, you can switch the order of multiplication and or switch the order of addition, right? And you still have the product rule. Well, first function is x, and we multiply that by the derivative of the second function, or the derivative of y, we denote with dy over dx. And then we add the second function y and multiply it by the derivative of the first function. Well, the first function is x, and the derivative of x is 1. On the right-hand side, right, 10 is a multiplicative constant. We just carry it along. And the derivative of y, we denote with dy over dx. On the right-hand side, and so now you see we got to get all the terms of dy over dx on one side, and so inside parentheses here we have a term with dy over dx. But before we can isolate it, we got to carry out this multiplication by e to the xy. So we have to use the distributive property, distributed inside the parentheses. And when we do that, we have x times e to the xy times dy over dx. And then we add to that e to the xy times y, or y times e to the xy. So that's what we get after distributing e to the xy inside the parentheses. And then on the right-hand side, we have 10 times dy over dx. So now you see we got a term on the left with dy over dx and a term on the right with dy over dx. So we can bring this term on the right over to the left by subtracting it from both sides. And then we have this term without dy over dx, and we can move it to the right-hand side by subtracting it from both sides. So when we perform those two subtractions, we have x times e to the xy times dy over dx minus 10 times dy over dx. Right? I got this by subtracting 10 times dy over dx from both sides, bringing it to the left-hand side. And now when I subtract y times e to the xy from both sides, I get on the right-hand side, right, move this term to the right-hand side, on the right-hand side I have minus y times e to the xy. Now on the left-hand side, you can see I have a difference of two terms, each containing dy over dx, so I can factor out the dy over dx, either to the left or to the right. And I'm going to factor it out to the right. And so I have, in parentheses, x times e to the xy minus 10 times dy over dx. Right? dy over dx is a common factor in the difference of these two terms. And so I can pull that common factor out to the left or to the right. I chose the right. And then that has to equal what's on the right-hand side of the equal sign. Minus y times e to the xy power. And now we're almost done. To get dy over dx by itself on the left-hand side, I divide both sides of the equation by what's in parentheses here. And we're done. When I divide both sides by what's in parentheses here, I have dy over dx is equal to minus y times e to the xy power over x times e to the xy power minus 10. And that's our derivative, okay? dy over dx, the derivative of y with respect to the independent variable x, is equal to minus y times e to the xy over x times e to the xy minus 10. And we're done.